All right, thank you everybody who came out. This is awesome. Have you guys had a good day today so far? Sweet. And how many of you know what dependency injection is? All right, this is a good one. It's all right, I got some intro stuff here. And how many people use it right now in their apps? Okay, that's good. Well, background, my name is Sam Edwards. I'm an Android GDE, and I work at Capital One. I'm based out of Richmond, Virginia, and I work with teams in San Francisco, in Richmond, and in Washington, D.C. area. The talk today is on do-it-yourself dependency injection in Kotlin. It's something that, based on some limitations that we had on a project, we had to go ahead and implement this. I'm going to talk about how we did it, how it's actually really clean and easy to understand, and it actually, I think, will help you find dependency injection a lot more approachable and kind of understand the core concepts, and then show how we implemented it, and then give you the trade-offs of what you get out of it. Here we go. So, covered a little bit, but I'm going to share the story of how me and my team implemented do-it-yourself dependency injection. And whenever you see DIY, it means do-it-yourself. We're going to demystify the topic of dependency injection because right now you probably think dependency injection and you automatically think of Dagger and you automatically think of, oh my gosh, what do I do? And I thought I knew Dagger. There was the wallet app I used to be on, and on that team we had Dagger. I finally understood it. It was good. And then I watched one of the Android dialogue talks where they had Pierre from Square come on talk about it, and I was like, I don't know anything anymore. There's so many features of that, and it's really scary a little bit. So hopefully it'll make it a little bit less magical. And I'm also going to show you how you can implement a do-it-yourself method, if you choose. I'm not forcing this on you. I'm not saying this is better than anything else. I'm just saying it's a possibility, and I'll compare it to other things and why we had to choose it for our project. So the story is, the team I'm on at Capital One, I've been there a little over 4 years. It was Capital One Wallet. I was the first full-time dev hire there after we had some contractors, and we built that for 3 years. It had a lot of cool features like purchase notifications, tap and pay, like a competitor to Google Pay and Samsung Pay and stuff. But they had a lot of really cool features that they said, hey, let's put this in our big app because it has 15 million users instead of 2 million users. So our app went away, and our team became the identity team. So we are the mobile team for identity at Capital One. So our goal now was to create an SDK that could be used for authentication across all Capital One apps. Because up to this point in time, everyone that built an app had to go implement identity for themselves. So this is the first time we were tasked to build a complex SDK. We had a really nice app using a lot of great open source practices in Wallet, but this is the first time building an SDK. So there were like limitations that came with that, and some different ways you had to approach it. So I've kind of laid out product requirements and then technical requirements. So these would be from the product side, like the benefits that they see of reusability of code, what they want to see, and then our technical must-haves. So like I said, this SDK must be used by different apps and different code bases. So we can't make assumptions. We can't assume, because we do have partners in Canada and the UK and other things, so we can't really assume that anybody's going to use a certain library or a certain version or anything like that. We just have to be kind of a plug-and-play sort of solution. We can't assume that somebody's going to be using RxJava. We can't assume somebody's going to be using OKHTTP. We try not to assume anything like that, because if we make that assumption, then you as a developer, you get this new SDK, and you're like, well, why does it bring along JSON? Why does it bring along this? I don't like that. Or I have this version, and it has this version. You get all these problems. So that was a requirement. Wanted to stay lean and lightweight, kind of in that same respect. And you want to make it configurable. So like I said, there's multiple teams, multiple countries, and things of that nature, so we need to make it so they can make it work for them. On the technical side, our technical team would say these things. And this wasn't an official thing. I just thought about the things that we kind of embody. So we wanted reactive programming. We had done RxJava inside of Wallet. We liked it a lot. And so we ended up doing coroutines because the decisions for libraries were basically anything in the Android framework or support library we could use, and anything with Kotlin, because Kotlin's kind of now sort of part of it. At least that's what we told ourselves. Immutable data, which is part of functional programming, so we don't get crazy, we don't get weird changes of our state. We're in control of that, and we can write functional programming where you have an input, you have an output, and we can just write a single piece of tested code. Wanted modular code, so we can change things around. Single responsibility code, which kind of goes in hands with immutable data. Well-tested code, done tons of talks on testing. We're all about testing. We have like 80% code coverage now. Everything's automated on CI. Very, very big and important. And like I talked about, we want to avoid third-party libraries. Last two things, though, 100% Kotlin. We had been doing that for about a year, like a little bit of our code base, probably 25%, with Wallet, but now we had this like greenfield project. We're gonna do all Kotlin, and we obviously needed dependency injection because it enables a lot of these other things. So why 100% Kotlin? Kotlin makes coding easy and concise. I say this coming from my Java background, that like, now that I'm a Kotlin developer, I'm happy, and I can't just, even if I say that, you don't have to believe me. There's actually like surveys that have been done that say developers are more happy if they use Kotlin over Java. So it's true, it's a true fact by a survey. It also makes dependency injection a little bit easier and more concise, because if you did it in Java, it's this huge bloated thing, and with Kotlin, it's not so bad. So why do you even want to use dependency injection? For this guy in the back that hasn't used it yet or not know too much about it, why would you want to use it? You need it for testing. And you need dependency injection for testing because when you test something, you don't want everything that you're not testing to interfere with your test. So they call this Hermetic Testing, where you have your piece of code, and then maybe you have a network layer, you have a Bluetooth layer, you have all these other things that could affect your app, but you want to go ahead and like isolate yourself. So you send in a mock, and you control all the inputs so that you just test your one piece. So dependency injection is really awesome because you have your typical implementation, but then you can shove in whatever you want in your test so you have control. And it's always the same thing every time. We do a lot with mock flavors, so we have always an offline flavor that we can use to do all of our testing, and then we also use that in our tests, but then you can switch to a test QA environment or to a prod environment. You can build custom debug features. Like I said, you can do environment switching. And it just, in general, if you have dependency injection and you go by that principle, your code just ends up being more reusable because you're thinking about how, if I'm going to maybe change this one thing, how do I make my code so it'll respond to that correctly? And if you're doing dependency injection, it also discourages the use of static singletons. So instead of saying like this thing dot get instance, trying to avoid that as much as you can. It enables all the really cool things that I like to talk about. Like last year, I was standing on one of these stages in one of these rooms, and I was talking about espresso testing and taking screenshots during that. Like I said, like there's things like push notifications and networking and everything else that if you can control, then your test can be reliable and dependable and hermetic and deterministic. So it enables testing because you have control over all the dependencies that your app needs. And then I talked about building debug features at DroidCon Boston and how important that is to like enable your QA, your product, your testing, your development teams to go in, make small changes and see how the app reflects without having to make a custom build or anything else like that. And it also, another thing is you can like do mock flavors. So we use WireMock right now. We've used other mock servers in the past, but our mock version actually runs an HTTP server on the device. We're able to like kind of switch all of our configuration via dependency injection and use that. So anyway, dependency injection like kind of enables all these things. And if dependency injection is not magical, the only thing that is Disney. Dependency injection is inversion of control. So all this means is you're passing in dependencies and telling something to execute instead of saying, here are my dependencies I'm executing. And we'll kind of see what that looks like in a little example. Here's my attempt to be cool at Keynote. So you're going to execute code that has predefined dependencies already within inside of it. But if you want to use dependency injection, you're going to separate out your dependencies from your code. So when you execute this, you're executing your dependencies injected into your code. So you can swap out the dependencies whenever you want, and it's injected. So see, right? All right. So this is a really small, contrived example just to show like providing dependencies versus having them already. So this is a case where you'd have your dependencies already like predefined. So in your network configuration, you're saying my URL is localhost and use localhost server is true. So that's fine, but if you're going to change that, you can't readily change it right here. You're going to have to go ahead and like write a new version of it. If you use like a method called setter injection, what you can do is have each one of these be vars, which basically means it has a getter and a setter on it. And so you create a new object like you see in the bottom, config, and then you'd set the full URL, and then you'd set it to be true. So this is a little bit more because you are able to set the values. The only difference is it's not predefined. But it's still kind of gross and verbose. Gross and verbose. My new. So constructor injection is the most ideal way to do a dependency injection. And unfortunately, we can't do that on Android all the time because we have activities and fragments. But a lot of your code can use it. And that's like a key piece to do-it-yourself dependency injection. So in this case, your class would take in the inputs that it needs, and then it would do its action. So this is very basic, like I'm saying, and kind of contrived. But based on your base URL and port, you're able to compute your full URL. And then you're actually able to take in based on the full URL and see if it contains localhost to see if it is. So you're dynamically creating those, evaluating that. So the commonalities that you just saw between all of those little things is inversion of control is basically passing dependencies into the code before you execute it. That's it. It's easy. So you are probably asking, why did you do it yourself? Aren't there libraries that can do it for you? And I already answered, yes. So let's take a look. So common dependency injection libraries you've probably seen is Dagger, like we mentioned earlier, which is wonderful and scary. Toothpick, Coin, and Kotlin. Now I'm going to evaluate these in a little chart, which has nothing to do based on, it's all based on our requirements we had and not based on what you should do. Okay, so just take that as a grain of salt. But based on in our case, when we had to build an SDK, we had to worry about fast build times. So we wanted it as fast as possible. We didn't want any code generation. And we realized Dagger did code generation and Toothpick did. Code generation isn't bad, but it breaks incremental compilation, which means that every single time you make a change in it, it's going to have to regenerate all the code, and all your other code gets rebuilt. So it makes development a little bit slower, and Gradle's already slow enough. Flutter looks really promising because of that, but it's Kotlin's better. All right. Then we have a single instance. So this means that there's like one static instance or registry to deal with. And Coin is actually looking really good. Joe Birch is a GDE based out of Brighton, UK. And there's this free course now on caster.io that's out till Monday, but it'll be there if you pay for it. I watched this week because I'm doing a talk on dependency injection, and he did this awesome course. And I was my mind was blown. It's actually really nice. But the problem is there's like one main registry that if we're an SDK and you're an app, we're all going to be talking to the same registry, so I can't isolate what I'm doing. So even if this was around when we started this, it still might not be the right solution for what we're doing. But definitely check it out. So is it a single instance? Yes, so we have to throw that away. Finally, was it available at the time when we started this about a year ago? And Kotlin wasn't, even though it matches the other things. But the last criteria was, does this add another dependency to our library? And the answer was always yes, it adds something else. So that's why we chose to do it ourselves. We evaluated other things, and there's a lot more that goes into this, but I tried to just give some reasons why we went there. So do it yourself means, like, you watch the home renovation projects, right? Like, oh, it's so easy. I just knock down this wall and I have a beautiful countertop. But it's easier than that if your countertop doesn't need to look too pretty. So let's see. So it's not that much work. It's slightly more verbose, but because we're using Kotlin, it's not a lot of code that you're having to write. And if you want really advanced features that you get like within Dagger and other libraries, you're going to have to manually like build those, like dealing with scoping and things, which is absolutely possible, but it's just not something that you get right out of the box. For most projects, you just don't even care about it. It doesn't matter. But once you get to a certain scale, you have to worry about things like, getting out of memory and so forth. So you're not keeping it around forever. So this is really great in a simple use case where when you don't already know a dependency injection library really well. In my case, I did know Dagger pretty well, but it like had all those other things that weren't good for our project. But if the thing always is, it doesn't matter if Kotlin's great, but if you know Java and you love Java, don't care about Kotlin. Or if you love PHP and you're writing web services, all I need is a REST API. Like, just evaluate based on what you know, and if you can be productive and know people that can be productive with you, that's the main factors that you want to take into consideration. So there is this open source app that I've been working on for the past year and a half or so. And I kind of just, whenever I learn something new, I throw it in there. It's just called Shopping App to be like a generic shopping app. It's available on GitHub, and we'll look at it a little bit. So there was a pull request I made and merged in on July 8th. What that was Dagger to DIY. Yay. Look at this talk. I submitted it. So this was me, and there's more code in there than just this, but I used Dagger in this sample app because I wanted to like see that play in, but I said, we're doing this DIY approach. Let me try it in a like isolated environment, and so I did it in here. And then, of course, 41 minutes ago, I merged in all my updates that I've been making during my slides. So that's there. If you want to check it out, like I'm referring to some examples here, but that's a way that you can do DIY. Yeah, just real quick, what does that look like? You saw some pictures, but if we launch the app, we have it already up here in Android Studio. There are a few, like I was saying, I like being able to do debug features in like different dimensions. So I'm using build variants in this case. I have live debug, memory debug, and mock. So live is like a real Amazon endpoint I'm hitting. Memory means like all my values are in memory. And then mock is a local mock server running wire mock. So in this case, we're running live debug. So we'll run that. everything will work perfectly, and in 3 seconds, it'll be on the screen. So it's going to go out and use the live version, which I'm going to filter just for app. There we go. So on the screen, we have our category. This is our shopping app, so we're shopping different video game console systems. And if you see here in our networking logs, we actually went out and got a 200 from Amazon AWS categories. So I actually went out to some predefined data I had out there and fetched that. Now I can easily go ahead and switch over to mock debug, which will run the WireMock server, and then it will access all the things, it will run the app against that. So I'm going to clear out the logs. It's running it. And then 3, 2, 1. See, I've timed this many. Hold on. All right, so now it's using a local server. We can validate that from the backend here and say it was accessing localhost, but it's just, it's another server. It's returning back the API contract I care about and giving me all the data. This app, you can just kind of click through categories, items, add it to your cart, view your cart, log out, and log in. Doesn't actually validate password. OK, so that's what it is. We'll look at a few examples of how we make it so we can change environments and things as we go further. So swapping dependencies on a graph is super important so that we can do these sort of tweaks and configurations. Like we showed, we can do a mock server versus a live server or testing server. And the graph is, so what we're doing is we're putting all dependencies in a graph. And a graph is basically just a collection. It says it's a class that says, here are all my dependencies that I care about. And then you take that graph and you can put it into your code. So you can say, here are all my dependencies. You configure all of them there. We'll look at some examples of that. And basically, as long as you put those dependencies in your graph, then your code's going to run based on those. Or instead of just swapping out 1 or 2 things, you can create an entire new graph as long as it honors the same contract for what you need in that graph. So here's an example of the network graph that I have in this project. The only 3 things that it exposes on this interface, and I'm using the interface so that we can be a little bit more dynamic in the actual implementation we're putting behind it, but it exposes 3 repositories. And I do a repository because it could be remote, in memory, local. But you can access the APIs for categories, items, and user. What that actually looks like under the hood is more like this. At the end of the day, we just have these 3 repositories, though, the category, item, and user, and they're overridden from the interface. So I can pass around this network graph anywhere and use those items. So in our code, we have the network graph here. And there's actually more to it. It's a little bit verbose. But if we look back to our slides here, I have a really cool visualization. Yeah, so the network graph, we're only publicly exposing repos to people that we're injecting to, but there's a lot of configuration that goes behind that. We need to configure Moshi, OKHTTP, retrofit, the URL that we're using, and all those things are like values that we inject into our graph. It's just my code at the end of the day only needs access to these repositories about users and things like that. Oh, and the other note is, if you have used Dagger, a graph is similar to a component, just a group of dependencies. This is a session graph. So because it's a shopping app, we have to know, is the user logged in, what's in their cart, and save information about the user. So if they logged in once, it'll remember them. So inside of there, it's not as complex, but we just defined our 3 values to satisfy our graph, and that can be injected anywhere. So in this code, we have multiple graphs. So if we looked at our application here, it's implementing an app graph, which has a session graph and a network graph. Sorry if that's a little small. There we go. And then in our application, we are defining it here to be just our session graph, which is typical. And then we're actually injecting we're setting the network graph based on the dimension. So based on the type of configuration we're running. So in this case right now, we're on the mock dimension. So if I click into this, it's a Kotlin extension function, which allows me to return a network graph at the end. But I'm able to configure it up for local host and set up a mock network manager and do things. And also, if I switched over to the live configuration and then went back there, I use a wonderful IDE, I'll click on it, and this is completely different. This is our Amazon S3 live endpoint. Because S3 doesn't support post requests, I'm actually doing an in-memory thing where I'm just returning back live user when they log in, just so that we can use it. But all the other calls will actually hit Amazon. And yeah, so continue on. So multiple or nested graphs are okay, and that's because sometimes you don't want all of your objects defined in one place. If you have just networking stuff, session stuff, you have different modules, it makes sense to like just group those where they're needed. We use multi-module projects. I think we have like 15 now or 20 or something like that. But each module, if it needs like access to all those dependencies, it's actually going to create its own graph. So one thing that you can do is you can leverage the by lazy like language feature in Kotlin to delay initialization. Like so, if you declare something by lazy, it'll wait till you actually reference that object. It'll compute like the instance of it, and then it will like cache that for any time going forward. So the way that we could do that is when we want our app graph. Let's say that we don't want to spin up our network graph and our session graph all at once. We don't need a network maybe to start. So we can set it as by lazy, and that way when our app starts and we instantiate one of these, we're not creating everything at once. We're actually going to wait until somebody accesses the network graph in order to instantiate it. So this is just instead of having to initialize everything at once, you can go ahead and do a lazy instead. If you want to do factories like you can do in other dependency injection libraries, you can just provide a lambda. So lambda in Kotlin is an anonymous function that just will basically run a function and then return the result. And so this is an example if you were creating a database, you just call like a database factory, you'd create the database, and you'd be done. So down below the usage is just db equals db factory. And scoping, so this is like a more advanced feature, like I said. You're going to have to kind of implement that on your own. And we're getting to that point now, but majority of what you're going to do in smaller projects are things that don't have a huge memory footprint. It might not matter. So if you get to an advanced need like this, you might find that need for a library that's been tried and true and has these advanced features is for you. But based on our requirements, it makes sense for us to do this manually. So when you're going to set up these graphs, you actually want to create them on the onCreate of your application. And that's because in Android, that's the first time that you actually have you have access to your application context object so that you can actually build everything and it won't crash. So because it's a lazy graph here, if we just access it, we just call graph, it actually will call that lazy and then instantiate it. So if you don't have lazy here, if you try to if you just said val graph equals app graph this, because the application has not been created yet and onCreate has not called yet, it will actually crash. Yeah, so there's some other methods I'll go through to do it, but like you basically have to wait until onCreate's been called. So that's kind of the point here. And then another way that you could do it is you could have a late init var, meaning that like this is a variable I will initialize at some point. I promise. I promise. And then you go ahead and later on onCreate, I will go ahead and set this. Late init is something you want to try to avoid though, because it is a promise, and maybe sometimes your code won't come through. So if you do want to support a graph in a module, one problem that you'll find is you don't have an application context you don't have an application you can really rely on, right? Because you're in any app, you don't know whose application it is. So you're actually going to have to make a static instance, which is something we don't want to do, but when that graph is created, make a static instance. So anything that's within if you have an activity in your SDK, you actually can just say graph, give me your instance. So it's kind of we call it a sad hack in our code. But you have to make a singleton because it's unaware of the application. It doesn't have any control over what application it's in. So dependency injection on fragments and activities is why all of this is really hard. And it's because of the Android platform and how they create instances of activities, fragments, applications, and services for us. We can't just say new. Because like constructor injection, as you saw, is like the super easiest way to just pass everything in. So you have to do some hacks to make sure you do it at the right point in time. You have to wait until after the onCreate, but after that, you're pretty good to go. So this is an example of an activity where you wait until onCreate has happened, and then you're going to assign the graph from your application. So this is a case where you actually have access to your application object. And let's look at what that looks like in our code. So in this case, we have our app graph. Yeah, we're creating it lazily, so anytime somebody references this, it'll be instantiated. And we've also created an extension function down here that I guess I'm cheating and jumping ahead for. So we can do it like this, which is kind of verbose. So we can train an extension function, which will make it easier. So we can just say graph equals application.graph. And so this is an extension function on application itself, which will go ahead and cast it to my application and get the graph off. Because we actually own that app, we could have set that graph up on that object. So you can access the graph by using the by lazy thing like we talked about. That's one option. And another way of doing it is actually using git. So when you actually do just git equals, and we'll show it in code because it looks nicer. So where's my home activity? So I did this on a few things here, but like the session manager, you can define a private val, and I'll zoom in a little bit for all you people in the back. You can do a private val session manager, and you can just define a getter. So what this means is you're really just creating one function in your code that says get session manager, but in Kotlin it looks like a variable, and it's a private variable. And when you execute that getter, like essentially in the background, it'll generate a Java code being get session manager. It'll just compute this every time. So it will happen every time, but if it's something that there's only one instance of, it's a way to get around doing by lazy. And there's a little bit of an overhead if you do by lazy, because whenever you say that, there's an anonymous class that's generated, and so it's a little bit more like code that's being generated in your app. That's a little bit much, but yeah. Okay. So we're almost to the end here. Some pro tips. Well, I guess I get paid for this, so anything I do is pro, right? Well, not for right now. It's a Saturday. All right, so try to avoid late init var for any injected values. If you can, do by lazy or use that little getter hack if you know it's going to be there. We want to avoid late init vars because, like we said, it's a promise, and not everybody comes through on those. And because it can create runtime exceptions, and also vars are immutable state. That's one thing I didn't really touch too much because I didn't want to go too much into current libraries. But if you're going to inject with something like Dagger or something else that uses the add inject annotation, that actually has to be a publicly available like var. So it has to be something immutable, it has to be something mutable, and it has to be something that's public. So that's something that you typically don't want on your dependencies. Like I said, there's a downside of by lazy because it creates the anonymous class, and the git is another way to get around that. Okay, so this is how you're actually accessing the dependencies from the graph. I have the code that shows this too, but your login presenter, you want to pass in a session manager and a user repository. So you can say appgraph.sessiongraph.getSessionManager essentially, but that's kind of ugly. So what we typically do is whenever we're pulling something out of the graph, we do it at the very top of our code. And this is similar to how you'd see it in any other dependency injection framework, where you lay out all of your fields that you want to be injected, and then they're satisfied. Or in this case, we're having to do a little manual coding to make sure that all these dependencies are satisfied. But at the end of the day, the code is much more readable, and especially if you have more things that reference a session manager or a user repository, it'll be a lot easier later on to read this. All right, last slide. Key takeaways. You don't have to use a dependency injection library. So we didn't use one, we're not using one. It's okay not to. So bye Dagger, I kind of miss you, but at the same time, it's nice, I needed to move on for this project, whatever. There are no magic annotations. So the add inject annotation I didn't go into very much, but if you've seen that, you're probably like, how does that work? Because that's what I thought for a long time. Kind of get it now, but still, it takes you a long time to understand, and every library does it a little bit different. With using Kotlin, this is pretty concise and straightforward, the way that you can write private vals, override them, do named parameters whenever you create something, makes it pretty easy. And just the key takeaway is if you haven't used dependency injection or you're thinking about it, no matter what library or however you do it, please use it, because you'll be happier and everybody else will be happier, because your code is not just the single purpose code. It can be used in any configuration that you provide in, and it can be tested, and everybody will be happy. So thank you very much. Again, I'm Sam. I work at Capital One, and my team is hiring. My team specifically, so if you want to write Kotlin and DIY and coroutines and also MBI, awesome talk on MBI, then yeah, come join us. We're in main office in DC. I'm in Richmond, Virginia, and we have a team in San Francisco I work with. So any of those. Thank you very much.